Okay. Hi, everybody. I'm sorry I'm not in class with you right now, but I'm going to be teaching you today about stoichiometry. Okay. And stoichiometry is basically a way for you to determine how much you can make in a reaction from a given amount of one of your reactants. So let's take a look at this old family recipe of mine. Okay. So we've got 2 slices of bread, 1 slice of ham. That gives me 1 ham sandwich. Okay. So if we want to make 2 ham sandwiches, we need 4 slices of bread, 2 slices of ham. Okay. So if we have 6 slices of bread, I could probably make 3 sandwiches, right? Okay. But what if I had 14 slices of ham? And how many sandwiches could I make? Well, let me see if I can set it up in a T-chart. Let's say 14 slices of ham. And I know that for every 1 slice of ham, I can make 1 sandwich. The question is, how many sandwiches can I make? Well, slices of ham cancels out. So I'm able to make 14 sandwiches. If I have 21 slices of ham, so I'm going to write what I'm given, 21 slices of ham. And I want to make the maximum number of sandwiches. How many slices of bread will I need? Well, I know that for every 1 slice of ham, I need 2 slices of bread. So for every 1 slice of ham, I need 2 slices of bread. So slices of ham cancels out, and I'm left with slices of bread. So that means I need 42 slices of bread. Okay. So we're going to use a reaction, a chemical reaction, and I'm going to actually highlight it here because it's a little hard to see. There we go. 3 of substance A and 3 moles of A, 2 moles of B gives you 1 mole of B2A3. So what we did with the example of the sandwiches without realizing it is that we used the ratios of the items to predict how much of the other things that we would need. Okay. So if I have 6.5 moles of B, how many moles of B2A3 can I make? Let's see. If I have 6.5 moles of B, and I want to figure out how many moles of B2A3 I can make, I first need to get rid of moles of B and get to moles of B2A3. Okay, so that I know that it's a 2-to-1 ratio. That for every 2B, I get 1 B2A3. So now I'm going to say moles here as well. Okay, so moles is going to cancel out. And I'm going to have 6.5 divided by 2. So it's going to get me, I'm going to say moles here as well. Okay, so moles is going to cancel out. And I'm going to have 6.5 divided by 2. So it's going to get me 3.25 moles of B2A3. Okay. Now, if I want to make, oops. Oh boy, I went way too far. If I want to make 8.7 moles of B2A3, how many moles of A do I need? Well, I know the relationship between B2A3 and A. I'm going to re-highlight that whole thing. Okay. It's a 3-to-1 ratio. So if I have 8.7 moles, that's what I want, of B2A3, I need to get rid of moles of B2A3 and get moles of A. Well, for every 1 mole of B2A3, I needed 3 moles of A. B2A3 moles cancels out. So it'll be 8.7 times 3 is 26.1 moles of A. Okay. Now, I lost it again. If I have 18.4, I'm going to write that down, 18.4 moles of B, how many moles of A does it need to react with? Well, in my reaction, A and B are in a 3-to-2 ratio. Okay, so for every 2 moles of B, I get 3 moles of A. Moles of B cancels out, so I'm going to do 18.4 times 3 divided by 2. Gets me 27.6 moles of A. Okay, so now we've been dealing with these theoretical examples, and now I want to start dealing with chemical equations. Okay, so if you know one thing about one of your substances that's involved, you can find out the number of moles of that thing, and using your mole ratio, you can determine the moles of something else and the mass of something else if they're asked for that as well. Okay. So let's say I wanted to get, the mass of substance. If I give you, let's say you start with 50.0 grams of substance A, and I want to know how many grams of substance B I can get. Well, I can follow this path. I can take that mass, divide it by the molar mass, and get moles of substance A. Then I can use my mole ratio to switch over from substance A to substance B. Now that I know how many moles of substance B I have, I can use its molar mass to get me to mass of substance B. Okay, so we're going to try some of these with some examples. Okay, so example 1, example A, I guess. Ammonium sulfate is made by this reaction. There's 2 NH3s plus H2SO4 gives you NH4 2SO4. And just to simplify this, I calculated these molar masses for us already so that we don't have to do them during the problem. So if I want to make 4 moles of ammonium sulfate, how many moles of H2SO4 do I need to start with? So I'm going from, I'm going to highlight this in blue, moles A to moles B. So this should be a pretty quick change, okay? So if I have 4.0 moles of NH4 2SO4, okay, well, I know for every, look at our formula here, for every 1 mole of that, I also use 1 mole of this. I use 1 mole of that. So it's going to give me 4.0 moles, but let's do it anyways. In 1 mole of NH4 2SO4, we use 1 mole of H2SO4 because that was our mole ratio. We used our mole ratio to switch from one substance to the other. So we're going to cross off moles of NH4 2SO4. Okay, and we're going to get 4.0 moles of H2SO4. Okay, let's move to the next example. If I have 2.5 moles, so I'm starting here, moles of A, of NH3, how many moles of ammonium sulfate can I make? So I'm going to go to moles of B. So again, it's just going to be a quick a quick exchange here. Okay. I have 2.5 moles of NH3. I'm going to write that down. 2.5 moles NH3. And if you look at our chemical formula up here at the top, for every 2 moles of NH3, we get 1 mole of NH4 2SO4. So I have to do 2.5 moles of ammonia and divide it by 2. So it's going to get me 1.25 moles of NH4 2SO4. Okay, that was just a mole to mole conversion. Now we're going to make it just a little bit more complicated here. Now we're going to bring in grams. Okay, so if actually, you know what I want you to do here is I want you to stop here on this video, come back to it and watch and do 24.1, which is watching a video on mole ratio video. It's about 20 minutes. But that way, I want you to have a really good understanding of that. You're going to be taking notes on it and then come back to my video after that. So just pause this video and watch that video. Okay? All right. So welcome back. Okay. So if I want to make 25 grams of ammonium sulfate, how many moles of NH3 do I need? So here, I'm starting with a mass, and I want to get to the moles of something else. So this is longer than we've done so far, but we can still get this done. If I can start with mass of NH4 to SO4, I can use my molar mass to tell me how many moles I have. Moles of NH4 to SO4. And then using my mole ratio, I can determine how many moles of NH3 I have. Okay. So what I like for you guys to do when you're working on these problems is to circle your beginning and your end point. And that's going to inform the number of steps that you're going to do. Okay, so I'm going to start with 25 grams of NH4 to SO4. Okay. And I have to use its molar mass to get me the number of moles. Well, in 1 mole of NH4 to SO4, I'd written it up on another page, but I have it here. It's 132. I had already gotten these molar masses calculated for us. 0.134 grams of NH4 to SO4. This is why I was such a stickler for full labeling. Okay, because here we're switching over from grams of this, moles of this to something else. Okay, so now we've gotten to, let me highlight my little journey here. We've gone from here to here. Okay, so we've got another step, and that's going to take our mole ratio. All right, and we have to look back at our equation. I'm just going to write it here for us that we have 2 NH3s plus H2SO4 gets us NH4 to SO4. Okay, so my mole ratio is going to be, since we're going to moles of NH3, it's going to be 1 of these to 2 of these. So since moles of ammonium sulfate has to go down here, NH4 to SO4, and 2 moles of NH3 goes up here. Okay. Now we have made it all the way to our destination. So let's see if things cross off for us. We've got ammonium sulfate crossing off, grams of it. Now moles of ammonium sulfate cancel out, and you're left with moles of NH3. So I'm going to do 25, my calculator, 25 divided by 132.134. Then 2 is in the numerator. So I'm going to get 0.38 moles of NH3. And that unit is coming from right here, moles of NH3. Okay, so we went from grams to moles now. So let's see what else we can do. Now we're going from grams to grams. Okay, so things are getting a little bit more complicated, but that is okay. All right. We're starting with a mass of ammonium sulfate, which is NH4 to SO4. And we want to get the mass of NH3. Okay. So the way we're going to do that is we're going to start with the mass that we're given. Mass of substance A, we'll just say A, so we don't have to write out all their letters. We're going to go to moles of A using our molar mass. Okay, and I actually have that up top here. We're going to go from moles of A to moles of B. Okay, and we're going to do that with our mole ratio. This is the new thing that we're learning. Okay, they're the coefficients in the chemical equation. Okay, and then for moles of B, we're going to use its molar mass to get us our grams of B. Okay, so this is going to take a lot of steps, but we can, now that we have a plan, we can be sure that the steps that we're taking are correct. Okay, so let's start with what we're given. We have 150.00 grams of ammonium sulfate, NH4 to SO4. Okay, we got to get rid of grams and get moles by using the molar mass. Well, in 1 mole of NH4, oh boy, I didn't leave myself enough room here. To SO4. Up here is where it tells me it's 132.134 grams of NH4 to SO4. Okay, so now I've gotten myself to here. I'm at moles. Cross off what I... So grams of ammonium sulfate are no longer. Now we have moles of ammonium sulfate. Now we can go from moles of ammonium sulfate to moles of ammonia by using their mole ratio. I know that moles of NH4 to SO4 has to go down here because I need it to cancel out. So moles of NH3, which is ammonia, has to go up here. And it's a 1 to 2 ratio based on this equation up here. Okay, so now, based on my mole ratio, I've gotten to myself to this point. Now, the last step is to use my molar mass and get myself to the mass of ammonia. Because now, if we're looking at what's canceling out, moles, get you to cancel out here, moles of ammonium sulfate have canceled out. So now we need to get rid of moles of ammonia. 1 mole of NH3 gets us 17.031 grams of NH3. So now moles of NH3 cancels out. Okay, so we're going to put this in our calculator. Change that back to black. We know that our units are going to be grams of NH3 because that's the only unit that we're left with. So I'm going to do 150.00 divided by 132.134. Since 2 is in the numerator, it's going to be multiplied times 17.031. Okay, and as my answer, I get 38.668 grams of NH3. Okay, and if you need to review that, feel free to pause it. But we got rid of grams and got moles. Then we went from moles of that substance to moles of another substance. And then use the second substance's molar mass to get to its grams. Okay? So we're going to do one last example together. Okay, and if you've already done the 24.1 assignment, then you're all set for homework. Okay? So we're starting with mass again. We're starting with 18.5 grams of sulfuric acid. And we want to get to grams of ammonium sulfate. Okay. And I'm going to write my equation down here. 2NH3 plus H2SO4 gets me NH4 to SO4. Okay, so I have to go from mass H2SO4 to use its molar mass to get to moles. And then use the mole ratio to get me from moles of H2SO4 to moles of ammonium sulfate, NH4 to SO4. And then once we know the number of moles of that, we can get grams of NH4 to SO4 by using our molar mass again, just the other molar mass. Okay. So let's start with what we're given. We're given 18.5 grams H2SO4 to get rid of grams and get moles. So in 1 mole of H2SO4, there are 98.07 grams of H2SO4. It's given to you up higher on this document. Okay. And then the mole ratio, it's a 1-to-1 mole ratio. So I'm going to put moles of H2SO4 on the bottom. You can't skip this step because you still need it to be able to switch over those units, those substances. 1 mole NH4 to SO4. Okay, so now we've gotten rid of moles of H2SO4. Oh, and we've also gotten rid of grams. So now for every 1 mole of NH4 to SO4, you get 132.134 grams of NH4 to SO4. So moles of ammonium sulfate cancels out. So you're going to do 18.5 divided by 98.07. You don't have to put the 1/1 in the calculator. You don't need to do that. Times 132.134. And this gets you 24.9 grams of NH4 to SO4. Okay, that's the end of today's video. And if you've watched the other video that I instructed you to earlier in this video, then you're all set for homework. And then I will see you guys next class. Thank you.